Hi everyone, greetings from Mentormatics. My name is Rini Thomas and I am really pleased to be your instructor for this course. Let me first give a brief introduction about myself. As a student, you might want to know who I am and whether I am qualified enough to teach you this course. Regarding my educational background, I have a Bachelor of Engineering degree in Computer Science. And regarding my professional experience, I have around 17 plus years of professional experience working in many multinational companies in India and abroad. I have worked on many real-world applications and projects and worked mainly on technologies like C Sharp, Microsoft ASP.NET, and Node.js as backend, and HTML, CSS, JavaScript, Angular, and React as frontend. Also, I have worked as a corporate trainer, training many freshers after they have been hired and making them job ready. Okay, that's all about me. Let me see you all in the coming lectures. Thank you. Let me give a brief introduction to this course. This course is the second part of the three-part C Sharp tutorial series. In the first part, I talk about the fundamentals of C Sharp and procedure of programming. In this course, our focus is purely on classes, interfaces, and object-oriented programming. Note that object-oriented programming is a complex topic and it takes a lot of books, videos, and years of thinking to really master it. But this course really opens your eyes to object-oriented programming concepts as I am using real-world examples to teach you. In the third part, I cover more advanced topics. Whether you want to use C Sharp to build web apps, mobile apps, desktop apps, or games, understanding the C Sharp classes, interfaces, and principles of object-oriented programming is crucial. You will learn the principles of object orientation, including encapsulation, inheritance, and polymorphism. I will show you why encapsulation is more important and how it helps in writing robust code. Then I will talk about inheritance. Inheritance is a way to reuse code, but unfortunately, it is misused a lot by a lot of amateur designers and developers. I will show you the problem with inheritance and I will introduce you to the concept of composition as a more flexible way to reuse code. Then I will talk about polymorphism. I will show you how you can take a piece of code that has a lot of if, else, and switch statements and refactor it into an object-oriented style. You will learn how you can change the behavior of an application by extending it. So instead of changing the existing code, which may affect many parts of your application, you create a new class that change the behavior of your application. And this is extremely powerful. And finally, I will talk about interface. So whether you are brand new to the concept of classes, interfaces, or object-oriented programming, or you have some experience, you are going to get a lot out of this course. I will show you how interfaces improve the testability and extensibility of your application. So you will see an introduction to unit testing and how we can use interfaces to improve the testability of our application. I've been really excited about this course and I hope you will become a better developer after attending this course. That's enough introduction for now and let's get started. In this lecture, I'm going to introduce you to the basics of classes. I'm going to show you a real-world example of a class and why we need them. Then I'm going to talk about what is an object and how it is different from a class. So, what is a class? A class is simply a building block of a software application. So, in the real world, an application consists of multiple classes, each responsible for a particular behavior in the application. And overall, all the classes together will provide the behavior expected from the application. Now, let's take a look at the real world example. We all are familiar with the concept of blocks and posts. Let's say we would like to implement a web application as a blog engine. With a typical layered architecture, our software application consists of at least three layers. First one is the presentation layer. Second one is the business logic, which is also referred to as a domain layer. And third one is the data access, which is also referred to as persistence layer. In each of these layers, we can have classes. Each is responsible for something particular. For example, in the presentation layer, we can have a class like post view, which is purely responsible for displaying a post to the user. In the business logic or domain layer, we can have the concept of post itself. And finally, in the data access or persistence layer, we can have a class like a post repository, which knows how to save a post to the repository or loading it from a database. A real-world application consists of hundreds or even thousands of classes collaborating with each other. So for you as a C# programmer, it is absolutely crucial for you to understand classes and how to use them effectively to build and maintain clean, robust, reliable application. So this lecture is pretty basic, but as we progress in the course, in every lecture and in every section, I teach you something new about classes. By the end of this course, you are going to learn a lot of materials about how to use classes and interfaces to build loosely coupled, extensible, and maintainable applications. So let's continue our journey. Now we know a little bit about a class. So it's a type we developers define and give it a responsibility depending on the kind of application we are going to build and the layer that class belongs to. Then what is inside a class? A class essentially has two parts: data, which is represented by fields, and behavior, which is represented by methods or functions. Let's take a look at an example. We talked about blogs and posts. So a blog post can have attributes of fields like title, description, and date and time, and it can have methods like publish, like, or comment, which receives a message. A term that is often used with classes and sometimes used interchangeability is an object. But an object is fundamentally different from a class. Yet a lot of developers, including myself, sometimes use the word object to refer to a class, but an object is essentially an instance of a class that resides in the memory. So in our example, another example, person. If person is a class, this one, it can have objects like John, Mary, Scott, etc. These are instances of that person. The person class or person type defines the blueprint from which we can create objects. At runtime, these objects in the memory talk to each other, and as a result, we get the behavior expected from the application. Now, let's see how we can declare a class in C#. Here's the basic syntax for declaring a class. Public and class are keywords or reserved keywords in C#. Each class should have a name. Public is what we call an access modifier, and that's something you are going to learn later, so don't worry about it. Each class should have a name or an identifier like person. In terms of naming convention in C#, we use Pascal case to name our classes. What is a Pascal case? In Pascal case, first letter of every word should be uppercase. We also have camel case in which the first letter of first word should be lowercase, but the first letter of every word after that should be uppercase. In C#, we use camel case when naming parameters of methods, as you will see later in the section. So back to the declaration of our class. The class can have fields and methods, which we refer to as members of that class. We put members inside curly braces like this. We can declare a field for this class and call it name, this one. Similar to class, we can start with an access modifier, which in this case is public, data type for this field, and an identifier. Now let's see how we can declare a method in the class. So we start with an access modifier, and here is the signature of the method. So a method can have a return type. In this case, void means it doesn't return any value. It has an identifier introduced, and in brackets we can put any parameters that the method may need. Inside the method, we have the code, and here we can access any of the members of that class. So in this example, I am simply using console.writeLine to display the name of that person on the console. Okay. Now that we have a class, let's see how we can create an object or an instance from it. To do that, we use the new operator. See, person equal to new person. Uh, To do that, we use the new operator. So we start with the type of the class. In this case, person. We give an identifier, this one, and then we use the new operator along with the name of the class to initialize an instance of that class. Note that we are using camel notation for naming the person object. Now that we have an object, we can access members of that object, like accessing the name field and giving a value, or we can call one of its method, person.name equal to Lini or person.introduce. This is pretty much for this lecture. And in the next lecture, we are going to learn about constructors. I hope you enjoyed this lecture and thank you for watching.